Okay, so welcome back, and now we're going to introduce the sum and difference formulas. Okay, so that's what or identities rather. And so what we're going to start with is cosine, and so here's the sum and difference formula for cosine. Okay, so again, this is a very useful formula that you're going to want to use. Okay, so we have cosine of alpha plus beta is equal to the cosine alpha cosine beta. Notice the cosine is and the sine are on the same side, so it's cosine alpha times cosine beta minus cosine alpha sine beta, and cosine alpha minus beta is cosine alpha times cosine beta plus sine alpha sine beta. Okay, so now we're going to show, I'm going to prove this one. Okay, and then the other one is pretty much the same. Okay, so, or similar. So what I'm going to do is I set up a circle here, unit circle. So this is a unit circle. Okay, and what I'm going to do is I set up this triangle. Oh, let's make this O. Okay, so this angle POQ. Okay, and then let's connect these two points P to Q. Okay, so we'll have this distance here. Okay, so we have the distance PQ. Okay, now what I'm going to do is, first of all, notice that this angle is beta, so the angle here, the Q, this point here, so I have 2 points on the circle. Point Q makes an angle, right? Beta with the x-axis. P makes the angle alpha with the x-axis. Okay, and notice that the angle between the rays, the line segments, the radii, right? The angle between those 2 points is alpha minus beta. Okay, now what we're going to do is I'm going to basically create another triangle with 2 other points, A and B. Okay, and what I'll do is I'm going to put B at the x-axis. So this point is going to be B would be at 1, 0. Okay. Now notice Q, by the way, Q is going to be, again, I'm going to use the trig identities for x and y. So this is going to be cosine beta, comma, sine beta. Okay, that's going to represent Q. And then P is cosine alpha. So it would be cosine alpha, comma, sine alpha. Okay, now what I'm going to do is I'm going to make point A and B such that this is just going to be a rotation of the angle here. So I'm taking this triangle here and I'm just going to rotate it till it basically, this leg sits on top of the x-axis and this one is going to come to A. So that's the way I'm designing this. Okay, so I'm creating another triangle. Let me do this. Okay. So I've got that angle. So now what I'm going to do is I'm going to take AB, right? Okay, now, so again, all I'm doing is I created another triangle, and it's just one triangle is a rotation of the other triangle. And so naturally, the distances from the distance PQ is equal to distance AB. Okay. So now, because again, that's true. We know that to be true based on our construction. So now what we're going to do is we are going to find the distance PQ and distance AB. Now, B is located at 0.10. A, on the other hand, is A minus B. Or not A minus B, alpha minus beta. So this is going to be cosine alpha minus beta, comma, sine alpha minus beta. Okay? Because again, this angle here, from here to here, is the same as the angle between the two rays, right? So this is also alpha minus beta. Okay, so now that we got everything labeled, now it's just a matter of using the distance formula. Okay, so now let's do distance PQ. Okay, now it's going to be what? It's going to be the difference in the x's squared, right? So PQ, so it's going to be cosine alpha minus cosine beta squared plus sine alpha minus hold on, sine, sorry. Okay, so that is our setup. Okay, so now this is where we just have to make sure just want to make sure I set it up right. So we just want to make sure that when we simplify this, we don't make any mistakes using algebra. Okay, so the first thing we're going to do is expand this out. Okay, so once we expand this out, then we're going to have to manipulate things to be able to use the Pythagorean identity to simplify underneath the radical as much as we can. Okay, so now I'm going to write this over here. So again, just follow along. So this is going to be the square root of, this is going to be cosine squared alpha, okay, minus 2 cosine alpha cosine beta plus cosine squared beta. Okay, that's just the first piece. Now we're going to do plus, and I'm going to continue underneath here, plus sine squared alpha minus 2 cosine, oh, not cosine, sorry, sine alpha, oops, keep, sine beta plus sine squared beta. Okay, so now that's all underneath the radical. So now notice that we have a, excuse me, cosine squared alpha and a sine squared alpha. And we have a cosine squared beta and a sine squared beta. Well, we can put those together because it's plus, right? These are positives, right? So we can put them together so we can move things around and those will become 1, right? So let's do that. So we can simplify that, okay? So this is going to become 1 if we group these together, and these are going to become 1. So we can, what we're going to end up having is, well, let me write this a little higher. What we're going to have is this is going to end up becoming 1, and then this is going to end up becoming 1. So 1 plus 1 minus what? 2 cosine alpha cosine beta minus 2 sine alpha sine beta. Okay, so now what do we get? We get 2 minus 2 cosine alpha cosine beta minus 2 sine alpha sine beta. Okay, so now there's that. Now notice, this looks almost like this. Okay? So now let's do this. So we found as much as we can with this. Okay, now let's do AB. Okay, well let's do the same thing with AB. Okay, well distance AB is going to be, again, x is first. So it's going to be the square root of what? Cosine alpha minus beta minus 1 squared plus, and then it's going to be sine alpha minus beta, and again minus 0, so it's just going to be sine alpha minus beta squared. Okay, now let's expand this out. Okay, so now that I got that, I'm going to make some room, so I'm going to erase this. Okay, and so this is going to be equal to, this is going to be cosine squared alpha minus beta, right? Minus, in this case here, it's just going to be minus 2 cosine alpha minus beta, right? Plus 1, and then plus sine squared alpha minus beta. Again, all underneath the radical. Okay, so now we're going to use the Pythagorean identity again. Notice that we have cosine squared and sine squared alpha minus beta. So we can put those together, and that's going to equal 1. And then we can add it to that one. So what do we get? We get 2 minus 2 cosine alpha minus beta. All right. Now, this is where we're going to put both of these equal to each other, and then this is where it's going to come apart. Okay? So now what I'm going to do is I'm going to erase up here, and I'm going to set this equal to each other. So I get this, so we get the square root of 2 minus 2 cosine alpha minus beta is equal to the square root of 2 minus 2 cosine alpha cosine beta minus 2 sine alpha sine beta. Now I'm going to square both sides, right? So I'm just going to square both sides. I'm just going to get rid of the absolute values because I can do that if I square both sides. The roots, the square root symbols go away, the radicals go away. Okay. Okay, so now notice that I've got a 2 over here and a 2 over here, so if I subtract 2 from both sides, these go away. Okay? Now, if I factor out a negative 2 here, well, what is it going to get? I'm going to get a negative 2 times cosine alpha minus beta is equal to negative 2 times the quantity cosine alpha cosine beta sine alpha sine beta, right? So all I do is just factor out a negative 2. And now notice when I divide by negative 2 on either side, the negative 2's go away. Boom. And I end up with the result that I wanted. And there's the identity. Have a great day.